Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
Existing infrastructure like what's provided by the mobile network operators can really solve a lot of these problems. We all have a cell phone in our pocket. Why isn't that the number one way we share position information and then lean on other things if you don't have cell service? But I think that we need to look at things differently. We need to look at the idea that third-party systems aren't bad. If it's not aviation grade, it doesn't mean it's not beneficial. How do we balance safety as well? Drones can do a lot of good, even if there's some risk. And we just need a holistic approach to looking at that. So I hope we get to a more cooperative sense of sharing information for the purpose of safety as number one. And then we look at a risk-based approach to allow for drones to do the good that we think that they can do.
Hey, welcome back to The Vertical Space and to our conversation with Chris Kucera, co-founder of OneSky, where we talk about the fascinating but complex world of UAS traffic management, or UTM. This is our second podcast discussing UTM, and although both podcasts have been terrific, I'm sure we'll have more in the future. UTM is a rapidly evolving area, and it's done differently throughout the world with various degrees of application and value. Listen from Chris to what UTM is, how it's formulated, its value, when it's needed and when it's not. UTM has some similarities to traditional traffic and air traffic management, but as you'll hear in our conversation, it also today has distinct differences. It has evolved throughout the last 10 years, and Chris has been very closely involved throughout these years. So we're fortunate that he's able to give us his primer on UTM. Now, let me give you a warning. UTM can be a complex area, and Chris is gifted in explaining UTM and its components. Those of you who can really understand the complexity and value of UTM, you'll be better equipped to deploy, realize the value from, and invest in not only UTM providers, but also those who will operate their aircraft and services businesses going forward. Listen to the importance of operators sharing information, including positional information and the integration of synthesis of this information, and how essential this information sharing is to an effective, safe system, and the importance of integration depending on the type and altitude of airspace. We have a really interesting discussion around cooperative and non-cooperative aircraft, understanding aircraft intent, tactical and strategic deconfliction, and flight planning. Listen to the different types of UTM service providers and how UTM is deployed and by whom, and how they're deployed in the US and throughout the world, and a really important discussion of the EU's U-Space. I really like Luca's question and Chris's response about what data is needed for effective UTM. What data requires 100% accuracy and reliability and constant updates? In a conversation I thought was terrific and really important, what data is needed for different parts of the UTM process? Chris is a rock star in this area, so really listen closely to how he explains the data, its source, its value, and its application. Listen to how some UTM systems around the world are more centralized and others more federated, and the role of the FAA and other air navigation service providers with UTM throughout the world. It's great hearing how OneSky started, its unique advantages, and how they expect to provide value and make money in the years to come. We thank Chris for his in-depth, valuable conversation, and to our listeners, we hope you enjoy and learn from our talk with Chris Kucera as you innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Chris Kucera is the co-founder and head of partnerships for OneSky. Chris has more than 20 years of experience in the aerospace industry and 16 years history working with Analytical Graphics, an aerospace software company. He has had various roles at the company, from systems engineer to account executive, with focus on scheduling and communication systems. In 2014, Chris co-founded OneSky as a subsidiary of Analytical Graphics to focus on UTM solutions. Chris manages business relationships for OneSky and is responsible for customer outreach and industry engagement. He is an ACGA board member and also works with various organizations such as ASTM, ICAO, AUVSI, the Small UAV Coalition, and more to understand the state of the art in drone technology and keep us up to date on regulatory progress. Chris has a bachelor's degree in aerospace engineering from Virginia Tech. He is also a commercially rated multi-engine aircraft pilot.
Chris, we appreciate you being on the podcast. Welcome to the Vertical Space. First question we ask, is there anything that very few in the industry agree with you on?
I think looking at UTM, there's a lot of pushback on that in the community for UAS. And I think that there's pushback in the general aviation community for crewed aircraft. And I think the problem is the concept of everybody sharing their position and being cooperative. So when we looked at BVLOS and we thought about how we're going to see drones or drones see aircraft so that they can avoid each other, it's kind of an impossible problem without some sort of bending on both sides. So a drone is not allowed to use ADS-B out. We can't share our position, so a crewed aircraft can't see us. And if a crewed aircraft doesn't have ADS-B, the drone flying remotely is not going to see the crewed aircraft either. So something has to change. And in the draft rule, in the ARC, the rulemaking committee that we were part of, they suggested that crewed aircraft have ADS-B below 400 feet. And if they did, then the drone would avoid them. So that was the shared sort of responsibility. You allow us to see you, and then we'll get out of your way. But that had a lot of pushback from general aviation, because the sense is that we're going to go out and put expensive ADS-B on board our aircraft just so you can go out and fly and make money with drones. That doesn't make sense. Why do I have to do something just to allow you access to the airspace? So the concept of e-conspicuity in the US and forcing existing operators to share their position for the purpose of safety isn't very popular with everybody. And there's two reasons. One is the reason of privacy. They don't always want to be seen. And the other reason is because of cost. They don't want to implement something and pay for it. And then I'll just answer those two. The privacy side of it is a problem because if you're somebody like a crop duster and you're flying low and you're flying over a house that maybe you're breaking a rule, you don't want somebody to see you. So flying low, you're flying in hazardous areas and you might be doing things that are on the fringe of acceptable. And so I understand, maybe not wanting to shift there. The other one is cost, and you can't go out and buy aviation grade equipment and get a low cost thing. So we have to look at different ways to satisfy that community. And I think UTM is where it fits here, because we can allow for privacy in a network system. So you only see what you need to see, and it can be low cost because we're using existing capability like cell phones as transponders even, that tie into UTM and network people together because they're flying at low altitude and using existing infrastructure.
So the thing that very few agree with you on is just on implementation of the UTM?
Yeah, I think on the general aviation side, it's just on the why do I have to do something just to be able to go out and fly and, do something, meaning connect to a UTM network, share information. And I think on the UTM side, it's still not completely popular by everybody because they don't know what it means to them. How much is it going to cost for them to go out and fly with a UTM?
Right.
And they're scared of that. So they need to understand more about how to tie into a UTM, the benefit of it, and why it's a better solution over trying to equip your drone with a radar maybe that might be more expensive.
So let's start with the basics. What really is UTM, and is there a universal agreement on what UTM is supposed to be?
It's funny because Jonathan Evans was one of the first people to talk broadly about UTM outside of PK at NASA. And before he left the industry, he was talking about UTM being universal. So he used that word. I tend to think UTM is much more about cooperative. So I wouldn't even use the U. U is supposed to be UAS traffic management and for drones, but I think it has wide implications. What it is it's a network system where you can cooperate. You can send your tracking data in and try to share that. So just imagine I'm flying along in an aircraft. I have a Cub or something, and I want to share my position. I have a cell phone in my pocket. And I even have an app. Let's say I have an app that communicates with OneSky, and I'm sending that data to OneSky. And so OneSky knows where all these general aviation aircraft are. Well, does the FAA care? How are they going to get that information? What's the system to tie UTM into the air traffic management system so that we understand where people that are using like non-traditional transponder mechanisms to be seen? So we're relying on aviation grade and a system that's built for purpose for aviators, but for people that are generally outside of the ATM system, they don't have a solution. And I think that's what UTM is doing. It's taking people that aren't regarded as an aircraft or aren't within the ATM, they aren't integrated, to have something that's broadly available, low cost, and it has privacy and security associated with it.
And if I may, for the purpose, Chris, of primarily safety, efficiency, what's the real goal? Obviously, your first answer is going to be it's always about safety. But what drove the need for it? Now that we have all these vehicles that are in the sky and we need to be able to find some way to make sure they safely operate, what are the goals of UTM?
Yeah, no, it's a great point, Jim. And I will say safety, because if you are using a system that requires you to cooperate, you're not going to try to do something like break the rules. So you can't tie cooperative and security together. And that's where I think there was a big mistake with broadcast remote ID, where you're trying to say, hey, these guys that have a broadcast device that's going to be a transponder and they're going to put it on their drone and they're going to just tell me where they are before they go and do something dangerous. That falls apart. So cooperative ties to safety and non-cooperative ties to security, I think, just broadly speaking. Now, UTM has benefits into the security regime as well. So let's say we have a radar and the radar is detecting non-cooperative drones and we see 100 drones, but in the UTM we have 98 of them with flight plans and intent, and we know who's operating them. I can quickly tell you which two might be the problem. So if you have intent in a safety system like UTM tied to a non-cooperative security system, then I think that's the best of both worlds.
Can you describe how UTM evolved over the years? And just to simplify for the audience, can you explain the key functions that are needed to implement UTM? So for instance, flight planning and airspace system observation, notification, automated traffic deconfliction, and others. And what is the state of the maturity in the industry for each of these functions?
So UTM got started, for us, I guess the big date was the UTM convention. I think that was around 2015 out at NASA Ames, and PK Paramal Koperdecker is the NASA lead for UTM, and I guess is on the patent for UTM. So it was invented at NASA by PK, and then it was shared with the world, and suddenly there were these UTM service suppliers, and they wanted to share information from operators they would be supporting. So you have one UTM service supplier or USS in an area wanting to communicate with another USS that might be supporting other aircraft operators. And so you suddenly need standards. How are we going to share information and how are we going to implement that? So that drove us down the route of a testing campaign with NASA to understand what the requirements would be, and then also a standards development effort in ASTM. And out popped a couple standards, one on remote identification and another one on how UTMs communicate with other UTM devices. Those standards are now broadly accepted by UTM service suppliers, and the testing has reached a level of maturity recently here in the UTM field trials. So we just finished that this week out at Virginia Tech, and we demonstrated that we could communicate between UTM service suppliers in a way that was efficient and secure. It allowed the regulator access to understand what was going on, and it allowed industry to set up a mechanism for how you control what companies can get access to the system and participate. And we're starting down the lines of governance and how do we do this in an operational way? How do we know what it means to be good performance, and what do we do if an operator isn't performing well? How do we kick them out of the system, and how do we bring them back in once they're performing better? So those are the things that we're working on now, is operationalizing UTM. But it's been a long road from 2015 to, I guess, 2023. But there's been a lot of testing and maturity.
And so how mature are the different functions when it comes to flight planning for a drone operator and integration with the airspace system, deconfliction? What has been solved? What still remains to be solved?
So the standards talk about UTMs, communicating, not the UTM with the operator. So an operator comes in with various systems. They could use commercial products. A lot of times we see Mission Planner, UGCS, or you could have a custom built ground control system. Maybe you have a fleet management system like Wing, which is completely automated. So the flight planning aspect of it is still controlled primarily by the operator, and they can use information from the system to do that flight planning if they want. If the USS is providing that kind of data, they call that supplemental data service providers. But the primary function of the UTM is to take the flight plan that's been computed and make sure that that flight plan is strategically deconflicted from other flight plans that are in the system. So let me talk about that for a second. Strategically deconflicted, first of all, it's strategic versus tactical. Tactical is kind of what we do a lot today when we're flying along. And if you have an ADS-B system on board, you could see another aircraft and then you could turn left or right. But you don't know its flight plan, and it didn't change whether you were going to take off at 12:30 or 12:45. You're just out flying and tactically deconflicting. Strategic deconfliction is important in the altitude regime we're flying in because there aren't sensors to know where all these drones are. And so if we constrain ourselves to a volume of airspace, we're going to fly along a path and we don't deviate from that path, and that path is deconflicted from another person's path, then we won't hit anybody. Now, as soon as you deviate, you're out of compliance, and so you have to come back into the flight plan or you have to land. So there's rules around how the UTM will force the operator to respond under certain situations. But typically we're getting the flight plan in, we're creating a volume, we're making sure that volume is separate from another volume that might be in the same airspace. So we're deconflicting it strategically. And then we're managing their conformance. We're monitoring whether they're staying inside that volume as they're flying along and alerting them if there's any other hazards along their way.
The biggest question I've had with that strategic deconfliction approach is really how far into the future are we able to predict the state of the airspace system? Mm-hmm. Because you have headwinds and you have, delays. Things don't always go according to plan. And if we're modeling this and we have certain error boundaries, and allowances around the state of the future system, where all the drones are based on strategic deconfliction, well, as you scale that up and as you push it further into the future, how far can you get before it really all breaks down?
Yeah, and there's lots more simplistic examples too, Peter, like some of the things that we've seen in flight trials where you plan a flight and then you go out to actually fly the drone and you find out that the place where you plan to take off from is underneath a tree. And so now you need to move the drone 40 feet to the left or right, and you're out of the way of the tree, but you're also now outside of your conformance volume. So suddenly you take off and you're already outside of the volume. So the purpose of testing is trying to find those edge cases. And what do we do? Do you have to replan, refile now because you moved your drone? Sure, certainly, you have to do that. But the basic capability is to file a flight plan, amend your flight plan, and then make sure you're flying strategically deconflicted. And it can be done quickly enough so that it can accommodate those amendments to your flight plan, even if it's in flight. There's also some error built into it, though. So we have a volume around the flight trajectory that's large enough to encapsulate the total system error of the drone. And we're still doing testing to learn what that is. And that number is different for every aircraft out there. So you have to lean on the operator to understand what kind of tolerances they can fly in. But it means how well is your GPS performing, or for navigation purposes, how well is navigation system performing? How well can you fly to the flight path? Because maybe the aircraft itself can't fly in winds that well. Maybe it's a fixed wing versus a quadcopter. And then what is the autopilot on board doing? Does it know how to fly the path that was designed in the UTM? Are they syncing up the autopilot versus the way the UTM understands you're going to fly that flight path? But let's build enough air around that. And then we take the volume and we segment it into time segments so that only segments are active when we think you're going to be flying through them. And the UTM can control what those segments are in time. So we can say that segment is valid for a minute on either side or 10 minutes on either side to account for any kind of wind issues and delay. But certainly being cooperative is all about, when there's a change, making sure you amend it and making sure everybody understands what the new plan is.
One of the common criticisms of UTM is that the emphasis on strategic deconfliction is really not something that operators need solved. Rather, they need something that will help them with tactical deconfliction. What's your response to that?
I think we're starting out with strategic deconfliction, and I think we'll add tactical as we need more of it. But right now, if you were to go outside and look up, there's no drones flying. So a tactical system, you might not hear anything back, but strategic is a sort of a better cost-effective way to implement the safety system right now. We can go out and we can reserve a slice of the airspace and we can fly within that volume. And if everybody is sharing their information, then we're going to be safe. There's still tactical things that need to be done by the drone, and larger operators have systems like vision detection to find a tree and stay away from it. What do you do with birds? What do you do with crewed aircraft that are flying in your low altitude airspace? So strategic doesn't solve all the problems, but it gets you one layer of safety and you can build on that. So I would say strategic is the middle layer. The first layer is really procedural. So if we were going to take the example of general aviation, procedural is if I'm flying westbound, I'm flying at an even altitude plus 500 feet. If I'm flying VFR eastbound, it's odd plus 500 feet. So we've already encouraged people to operate safely by just putting a rule that says, if you fly those altitudes and everybody does that, we're going to be safer. The next one is strategic, and that could be like, don't fly in military operations areas, stay away from restricted areas. And then there's tactical, which is we have ADS-B, but with crewed aircraft, we have eyes in our head and we try to look out for things. So it's all about layered safety. And so we're starting out with strategic and we're building on with tactical, and we'll learn more about tactical systems and how they perform as we get to fly more.
Chris, let me ask a little more of maybe a stem cell question here, and I may be taking a step back in the conversation, but just for the audience who may not be as informed, where is UTM deployed today and for whom? And where are those operators able to fly and not use UTM? Let's just say in the United States.
In the US, the UTM is not required, not mandated, and only used really under an R&D sense. So we're using it at test ranges. The UTM field trials just were finished, and that testing was done at the New York test site. It was done at Virginia Tech MAP, the Mid-Atlantic Aviation Partnership, with Texas as well as a partner with MAP. So we continue to do these trials with NASA or the FAA on using UTM, but I think this last trial we've kind of crossed the boundary of showing that it's a mature system and starting to realize that there's a lot of beyond visual line of sight flight operations out there. And we need to start thinking about what happens when two operators are flying in the same space at the same time. So fundamentally, you don't really need UTM for drone operations. If there's only one operator in that area, they're going to self-deconflict. But if you have two operators, you suddenly need something. There doesn't seem to be policy for what happens when a drone hits another drone because there's no people on board. So it's not really a safety issue as an air risk, but there is an associated ground risk if two aircraft collide and then the aircraft fall on people that are on the ground. So we need to pay attention to it even if there aren't people on board. So I think if you're talking about when should we be using UTM, under what densities, I'd push back and say, well, it's not really a density question, it's about an operator question. If you have two overlapping operators, we should start thinking about UTM. And these questions are just starting to come to fruition. And this applies to many other countries that we are doing business in. We see operators like Skyports doing operations, but no overlapping operations with other operators. So typically what they do is they get a transponder mandatory zone or a restricted area to do their flight operations. And so it's pretty much sterile. But if we're going to see drones and the operations scale to volumes that we started talking about in 2015, we're going to need something that allows for overlapping operations.
What data does UTM rely on? Where is it coming from? How can this data be trusted? And how does the FAA think about validating this data?
That's a really good question. And coming from AGI, our parent company, where we've done a lot of modeling and simulation, and we've built very high fidelity visual systems, 3D graphics, where you can put data in there, and once you see it, you believe it's the best data out there. So seeing sometimes is, and believing go hand in hand, but that doesn't mean it's the best. So we rely on so many different pieces of information today that we don't know the provenance of. So looking at geospatial data, for example, where did the terrain data come from? And how accurate is the terrain data? Same thing for buildings. Where did the building data come from and how accurate is it? Ultimately, you can put lots of data into a system, and if you don't know where it came from and you don't know the accuracy of it, then it's not going to help you much. So we need to focus on what's the critical data we need for something like UTM, and then how can we make sure we're not flying based on a map? Because if you go out and fly on a map, that map data is expired the second the data was surveyed, right? So it needs to be sort of a shared system where we can understand flight plans and sharing of trajectory information in a very standardized way. And when we're looking at doing flight planning and operations, we're relying on the ground control system. They understand that region and they're going to plan a flight that's safe for their purposes. So for UTM, let's just say that UTM is for making sure we're strategically deconflicting our aircraft. And the data that is crucial for that is flight plan data and trajectory information. And then we're looking at latitude, longitude, altitude, and making sure that that's accurate. So we depend on navigation systems. And how do we know that our navigation solution is good enough? We look at different altitude reference systems. And early on in UTM, we found many problems with people using AGL, above ground level, or MSL, mean sea level, or WGS 84, which is a reference system used more in space and GPS, but is common now in drones. So you have to know what systems are producing the data that you're getting, what the reference frames are, and then in a standard, making sure that we're using the same reference systems as we're communicating. But then underlying that, you have to know how well is the system performing. If there could be problems with GPS, how are you going to figure it out? And make sure that your system can understand when there are errors in the underlying navigation or surveillance or communication.
Right. And I guess we could throw in additional data as it relates to weather, as it relates to population density, or any other supplemental data that operators rely on to deconflict on multiple levels. So are these questions still being discussed? How open is the FAA to verifying, qualifying third-party service providers to provide this, certain cases, mission-critical, safety-critical data?
I think in the FAA, they're talking a lot about an associated element in terms of how it would be used with a UAS operation. So typically in crewed aircraft, you'd see certification, and the aircraft would be certified with certain devices on board, and those things are then aviation grade. They have been TSO'd, and so it just comes because of the certification. For drones, you could be flying an uncertified drone, and then you also have the aircraft itself separate from the ground control system and the pilot, who might be on the ground. And so the way that the FAA is trying to deal with that is calling that an associated element. It's not the aircraft. We can separate out the aircraft and test that and make sure it flies well. But how are we going to use it is the other question. How are you going to communicate? Make sure that you can command it. How are you going to navigate and surveil the area to understand what else is around you, and then submit flight plans and command the drone? So all those things are just the core parts, but you have weather and everything else thrown in. That supplemental data that could be used for flying the drone is all under that associated element sort of bucket. And not all of it has to be, certified. It just needs to be tested. It needs to be, you need to show that it can support your flight operation. At least that's how we've seen operators, get clearances to fly.
If you wanted to operationalize UTM, what data sets are you missing today that you would absolutely need to be able to make sure that it's an operational system?
That's a really good question. I think it just depends on the operator, though, because every operator is going to want to fly differently. And if I'm building my operation, I want to make sure that I know that my navigation solution is correct. I'm not on board the aircraft if somebody jams GPS. How do I know that's happening? And can I still locate my drone? So there's other ways of doing that. You could use other systems for navigation, like assisted GPS from LT, for example. Communications is another one. How do you know that you have redundant communications on board? So maybe that's the answer to the question is redundancy, making sure that whatever you have a redundant backup in operations, but behind it all, trying to understand the performance and understanding when the primary system is failing. I think, UTM, though, specific to UTM, that's the networked capability, right? So we're getting flight plans and tracks, and we're assuming all that data coming in is good. But how well should a UTM perform? How often should we be sharing track data? When is a UTM service supplier not flying well enough and should be kind of kicked out of the network because they're causing safety issues? And I think we're just starting to understand that as we move forward here on governance of UTM, what it means to self-govern a system and understand the performance thresholds for how well we need to operate. And a lot of it's learning and operations too. So we haven't really been out there using UTM for operations. We've been doing it in R&D. And I think we need to spread our wings a little bit and get some actual operational flight hours of the system in an overlapping way, multiple operators, multiple UTMs in one area. And learn how it performs.
Chris, it certainly appears that, and this is another criticism of UTM, that really is awareness more than management of traffic. So what will it take for the FAA to give another entity, whether this is a USS or something else, authority to manage drone traffic?
That's a really good observation. And when I was with Wing this week out at the UTM field trial, they were talking about M to N, which is, how many pilots can fly how many drones. And they mentioned how many that their pilots can control. And then there are different rules. It can be 5 or 50. But it's a lot of drones being controlled by one person. And then the questions are, well, how many drones could be controlled? When do you need another pilot? But that's the wrong question, because these drones aren't being controlled by the pilot. They're being controlled automatically. So it's not about traffic management. It's about airspace management. Because if you want to control the drone, you put in regions of airspace where the drone shouldn't be able to fly, and the drone systems fly around them. So if we look at the problem more from an airspace management problem than a traffic management problem, I think it simplifies things. And it puts a lot of burden on the flight command and control systems. How are they going to manage data that comes in where it says this is now a restricted area, or I suddenly am in a restricted area and I need to get out? But those are tactical things that can be done by the pilot, by these network systems. And we need to look at how well they perform in operations. So, I hope that helps, because I think that's right, that it's not about traffic management. It's more about airspace management.
But even, let's say that you do have some kind of reserved airspace, and I guess it really depends what kind of granularity you're thinking about. It can be as granular as the route itself. Perhaps this is what you're alluding to. But if it is larger, then you still at some point bump up against the problem of ensuring that drone traffic seamlessly operates and flows with no collisions, etc. So at some point, somebody has to take this management role, because with management also comes responsibility and liability.
Yeah, and when I think about management and the systems that we're building for, there's two sides of UTM. There's a USS, the UTM service supplier, which is really looking more at the operator. How do we take flight plans and track data in, and how do we get that flight authorized? Well, then there's the flight information management side of UTM. And these are systems that OneSky is deploying to different countries, where a country wants to build infrastructure for UTM before they pull in drone operators and USSs and allow them to go out and fly. So the flight information management system is controlling who is authorized to fly. If a flight plan is sent to a flight information management system, that flight could be approved autonomously if it understood the rules for how drone operations should be approved, right? So we can look at all different things of a flight plan. Is that flight plan flying in restricted airspace? Are the winds too high? Are there other weather impacts? What kind of communication systems are being used? What surveillance is being used, and are those surveillance systems able to see those areas? You can go through the whole system if you want to and put that in as a rule. But the goal is to codify the rules behind flight approval and make sure that that FIM system, the flight information management system, can automatically approve flights. And I think that's the type of traffic management, because we're talking about strategic deconfliction. We need to manage the approval of that flight trajectory and that flight volume, and make sure that you can fly that volume the way that you think you can in flight, and let the ANSP approve that autonomously, I suppose.
And then one step later, after the approval, the flights start. Who shares responsibility in this community-based approach and collaborative sharing and deconfliction?
I mean, anybody in the network would share responsibility, and that would include people that are providing data from the outside. So if you're low-level aircraft and you have ADS-B and that ADS-B data is being shared, we'll see it and we'll make it available to others in the network. In work that we've done in Australia, for example, low-level air traffic becomes a constraint in the UTM. So we'll track that aircraft, we'll make it a constraint, and it's dynamically tracking that aircraft such that all UTM operators in the network will see the aircraft constraint volume and stay away from it. So it's the flight operator for flying the way that you're supposed to within your volume, making sure that you have contingency plans, and it's the UTM service supplier making sure that they are building their systems to the standard and testing them with other operators, and then it's all this supplemental data service suppliers that are providing information like surveillance or weather into the system, and that whole system is an ecosystem that needs to have performance metrics associated with it so everything works well. And I think that's the point. That's where we are, is trying to understand what that needs to be for the system to operate well, and how does it change over time as we get more volume.
Where is UTM being most effectively deployed around the world today, and why?
UTM looks different across the world. So, we're working on a large contract in Australia with FIMS, Flight Information Management System, and I think they have a lot of experience in Australia with flying beyond visual line of sight. In Europe, they're doing a lot of beyond visual line of sight differently, using concepts like SORA. So it's a specific category of drone versus other categories you can have, and then it's operational risk assessment, SORA. And so you look at the flight path and you understand what kind of things affect your risk category. Are you flying in densely populated areas, for example? Are you flying in areas where you have high encounter risk with other crewed aircraft? And all those things impact your risk profile. And so it's a much more risk-based approach to flying a drone. In the US, we went down a certification sort of regulatory path for drones. I think we're trying to look more at a risk-based approach. But then the deployment of UTM is different. You have a very centralized view of deployment outside of the US and a federated view inside the US. And that just means who's sitting over UTM and making sure that it's running appropriately. So a federated approach would have a self-governing kind of system, a set of rules, and maybe a third party that's looking over the system and making sure that all the operators are operating efficiently. That could be a test range, for example, that is doing that. Or it could be just a set of automated testing functions that are run against the UTMs and understanding how well they're performing. But across the world, there's a lot of BVLOS use cases. I guess I would judge whether we're doing well with drones by the amount of BVLOS activity that you have. And I think that we're seeing that in many countries. They're just achieving it in different ways.
Chris, how is U-Space different? In what ways is EASA's perspective on UTM different than that of the FAA?
Yeah, so like the U-Space is a bubble for flying drones in an area where you have to have things like econspicuity. So econspicuity is everybody is seen. And since we know where everybody is, it's much safer and easier to fly. We don't have to have non-cooperative systems on board a drone or on the ground trying to find things. To find a small drone with a radar is not easy. And so it's easier if there's some sort of RF emitter device, whether that's a cell phone, LTE transponder, or if it's ADS-B or a FLARM type system. So by creating the bubble and then putting in the rule that you have to be conspicuous, it makes it easier. The UTM is also required to manage the conspicuity of the drone. So we'll have crewed aircraft flying through with traditional broadcast devices or new broadcast devices like LTE and a cell phone. But for the unmanned systems, we'll have UTM that will fly the same way I've described it: flight plan, tracking, strategic deconfliction. But that it's also in these small regional pockets. And that's different because in the US, we're looking at a rule that would cover the entire United States. Talk about it as like a light switch moment. It may take the US longer to get to a rule and get to BVLOS, but I think when we get there, it will be turned on all at once because there will be a rule that makes sense for everybody across the entire country. So for me, U-Space looks like just a smaller implementation of what we will probably get to eventually here in the US, or at least I hope we do, which is a rule that covers the country that says for safety, we're going to be conspicuous. We're going to share our information so that we don't run into each other. And frankly, if you're not sharing your information, I understand there's privacy concerns, there's cost considerations, but it seems like you're flying in the face of safety, and it's a little bit arrogant. And I think that there should be ways that you can share information that solve those issues that you have, whether that's privacy or cost. We need to make systems available so that you can share your tracking data. This is the 21st century, right? There's ways to share this data so that we don't have collisions, and we need to be doing that.
Chris, and when the light switch is thrown, let's say in the United States, we would take more of a federated approach as opposed to a centralized approach. Is that right?
Right. I mean, that's the posture here, is that we've been going down a federated approach for, since 2015. Multiple operators in an area, not much of a FIMS. I mean, in other countries, FIMS would include something like the DSS. We haven't talked about the components of UTM, but the discovery and synchronization service is an important function. It is a yellow pages of the operators and the SDSPs that are in an area. So I might register my UTM system, and Honor might register their UTM system. And then we might have a constraint service provider from Airspace Link. And that starts to build the network of what UTM is all about. So the discovery and synchronization service as a yellow pages makes sure that people that are in the network are supposed to be in the network, are performing the way they're supposed to be performing in the network. And it sets up the standards for how you communicate across the network. Like, we're going to use ASTM standards for understanding constraints, for understanding flight plans and tracking data.
Let's say that light switch is thrown, and let's say we have three companies. One is OneSky, one is Skydio, and one is Mana. It sounds like Mana is coming into the United States. I was just reading recently. Which company is going to most benefit from that light switch thrown for UTM?
Well, I mean, if you can already fly today without UTM, then it might seem annoying to have to use UTM to fly, right? So if somebody like Skydio could be out there flying BVLOS because their drone is light and they have the ability to get waivers to fly in different areas, maybe it's not as beneficial to have UTM in those types of operations. If you're doing flights with Mana, I would think that's more delivery flights. It's harder to get a waiver. You need to be looking out for things. Might be more beneficial for you to use UTM. And then certainly the UTM, if there's some sort of mandate, that's a great benefit to a UTM company. If the government's saying, you should use UTM to be conspicuous.
Would USpace be good for the US?
I think USpace is a good concept in that it allows you to figure out how to get your hands around something and start flying. So we could look at an area. Let's say we're flying, I have these thoughts about flying in a mode CVAL, where the mode CVAL is 30 nautical miles around a Class B airport, and there's mandates for ADS-B in that area, and it goes all the way down to the ground. So we could theoretically be flying below Class B airspace, but within the ADS-B mandate. And most aircraft should be using ADS-B. There's some that don't have to. They have waivers for not using ADS-B. But let's say we're flying in those mode CVALs. What if we created a bigger rule that's everybody should be conspicuous, meaning drones aren't avoiding this rule either. You have to share your information too. Then it becomes really interesting. So it looks kind of like a USpace area if we're creating a bubble around a mode CVAL and allowing people to fly there beyond visual line of sight if they're abiding by these types of behaviors. So I think what USpace does, it allows you a way to get your hands around it, try it out, and then see if it's going to work. I mean, what happens if USpace in Europe is so popular, they say, oh, this whole country is a USpace? I mean, it looks a lot like what I would think a rule would look like in the US, when we finally get there.
And how real is USpace in Europe? Who has implemented it so far? How do you see that rollout?
I'm not a pro on that, but to my knowledge, there's not many USpace areas. What they typically are doing these days are transponder mandatory zones, which is like the mode CVAL, where you have to have a transponder to operate. Or they're flying in restricted areas and saying, this is a bubble, everybody stay out, or just beware there's drone operations flying here. And so when we work with companies like Skyports, they're flying over the water and in areas that are, I guess, closed off to other operations, or at least notifying other operations that there's drones flying in those areas. And I think the transition, though, is the way that they're flying now is just along pathways. So they'll fly out and fly back on the same pathway. if we want to get to a delivery operation, we really need to get towards U-space, where that whole bubble area could be flown, where right now it's more, we're going to certify your path, we're going to give you away, but it's not going to be flexible for your daily package delivery operations. So I think U-space is still becoming more of a thing in Europe, but right now, from my understanding, more people are flying in TMZs and restricted areas as we get our hands around how do we create a U-space area. One problem with that, just real quick, is that when you create a U-space area, somebody can provide their surveillance, but the UTM needs to understand the surveillance as well. So let's say an aircraft is using FLARM. Well, how do we know where that aircraft is using FLARM? Do we have ground-based receivers to pick up FLARM data and then share that in the UTM? What if somebody is using an LTE cell phone transponder? What network provider are they using? How do we know as a UTM to go to that network provider and get data from them? So as a surveillance side to U-space, it can be quite complex. If we don't know all the different surveillance systems that are out there, then it makes it hard for us to get a decent situational awareness picture of what's going on in the U-space area. And I think that's probably the next hurdle we need to solve.
Chris, when you compare the approach with U-space, or more broadly, the European approach to airspace integration of drones or in other parts of the world relative to what we're doing in the US, do you, from your conversations across the industry, see any differences in the companies that are developing technologies in those different parts of the world? Is there an impact on industry from these different approaches to airspace integration?
I mean, certainly, if you just look at ADS-B and the way that mandates have occurred across the globe. So in the US, we have 1090 and UAT 978 megahertz use. So we have dual frequency here. And in other countries, they just have 1090. In other countries, they have FLARM. We don't use FLARM. We have something called tabs that we're trying to use here, which is based on ADS-B frequencies, but just used differently. And then there's other ways of getting data. So in some place like Canada, where you might have Aireon, which is a satellite-based reception of ADS-B. Now your ADS-B has to point up versus down. So you might have a need for two antennas on that aircraft, one to point down and one to point up. So the way you build your solution, it ends up being based on the regulatory approach to the systems that they're building to manage the airspace. And that certainly impacts UTM as well. So I don't know how to say it differently for a UTM specifically, because ours is based on networks. How do we communicate with each other? And we're all using basic internet communication protocols. So it doesn't impact UTM as much because we can pick any kind of communication system we want to transmit our position data. And I think that's the benefit of being cooperative. In the ADS-B world, it's much more of a mandated approach based on how those systems have been set up.
How do UTM and traditional air traffic management, ATM, interact? What are the interfaces? And ultimately, how do we get to a state where the two come together in this next generation traffic management of all vehicles that share the airspace?
I love this question because it comes up a lot. And, it brings me back to 2015, I guess, when we're starting to talk about UTM. And it's sort of the feedback we were getting from air traffic control was, don't show me all those dots on a map. I don't know what to do with them. But as we get closer to deploying a solution where BVLOS aircraft might come close to an airport, they do want to know about the dots. They don't want to see them all the time, but they want to see when they're impacting a flight that's under their control. And they don't really trust these drones flying underneath their airspace. If you're in a Class B airspace and suddenly a drone goes up into the Bravo airspace, that's not good for you as you're trying to control aircraft. So there's this trust factor. The integration is different at different altitudes. So at low altitude, it's generally uncontrolled airspace. They're not putting an instrument flight through 300 feet flight level. So it's not something that they traditionally care about down there, but they don't want a drone flying through a restricted area. So at a low altitude, the way that you integrate is just by providing information and saying drones should fly here, drones shouldn't fly there, and then making sure that drones just generally should be able to fly because they're safe. So then as you move up into different altitude regimes, you become more integrated. If you're an air taxi, you might have ADS-B out. You might be on an instrument flight path, but how do you communicate with air traffic control? Do you have a pilot on board, or is your remote pilot communicating with air traffic control over voice over IP? Is there a data link? Can we use CPDLC, or do we invent something new? And the FAA we tested with something called IP data link, which is like CPDLC, but over the internet. So communications, I think, is another one that we look at for ATM integration as you move higher into the airspace. And then I think, flight approvals is something that is another ATM integration function. If we're flying air taxis from vertiport to vertiport, how do we approve those operations? Is there an automated system, or is there an air traffic controller that's going to approve that flight? So we have to think about who's in control in different situations and what authority does ATM really want to have. And that's where the integration point is.
So one is centralized ATM, one is decentralized UTM, at least in the United States is how you're envisioning it. But there will be gray areas where I would assume FAA, as you're saying, Chris, the FAA will want the same level of control as they normally would with ATM.
I'm not quite clear on that, but I think that the ATM is always going to be managing the crewed aircraft, the manual aircraft, the things that are integrated into the airspace that's controlled. And then outside of there, it becomes gray. It's certainly not gray when you get into low altitude airspace where below 500 feet, there's not much aircraft flying unless you're in the close vicinity of an airport.
Yep.
And so then it becomes more the regime of UTM. So maybe at a high level, you're seeing that UTM ATM integration really happening where the gray area is, because otherwise you're completely in ATM or you're kind of completely in UTM with some data sharing elements. We want to make sure we're sharing trajectory information on an ATM and from ATM to UTM, but the control aspect, it seems to be more in the control of UTM low level and more in the control of ATM high level, and you don't need as much integration.
Chris, tell us a little bit about UTM companies. Who are they? What's worked? What hasn't worked? And how do they make money?
Yeah, I mean, UTM companies are all sort of different in the way that they approach the market. Early on, before Part 107 came out in the US, Part 107 allowed for commercial drone flight operations. I think that there was a thought that UTM might be involved in that. So you would have to go out and say, I'm flying a commercial drone operation at this particular location, and this is my bubble. I'm flying here. That didn't happen, and a lot of early UTM systems built towards Part 107, I guess, towards visual line of sight operations, and operators didn't really need to use those systems. Lance came out, which was a system that allowed you to have the authority to fly in a controlled airspace area. So if I'm flying close to an airport, it would allow me to fly up to 200 feet or 300 feet, whatever the FAA tells you is the safe altitude in the data that informs Lance. So Lance is the low altitude, I think, authorization notification capability is what they called it. So many early UTM systems did find business by providing Lance authorizations. OneSky was never focused on that. We were focused on beyond visual line of sight. And there still are Lance operators out there today. And other countries don't have Lance-like systems necessarily set up. So they might engineer something a little bit different as they move forward, maybe something more flexible. There are companies that doing UTM that are more USS, meaning that they're focused on the operator. How do we manage flight operations for a company, take their flights, take their trajectory information and share it in the network? It's something that we're interested in, but it's not our only focus. Our main focus, I suppose, right now is the flight information management system concept, which is the other side of UTM. How do we build the framework for UTM in a country so that they can manage the airspace the way they want? They can set the rules for where drones fly. They fill in the registry information for drones and who owns them. And then they can turn the dials for the thresholds of operations. Where do we want things to fly? What times do we want things to fly? And those rules then are autonomously controlling the behavior of drones in that airspace. So that's sort of like the big picture of where companies are. And today we still have, a lot of UTM systems that are really focused on visual line of sight and Lance and local data sets, where are schools, where are jails, where are parks and things like that, and knowing where it might be safer to to fly your drone operation.
How are they paid today? And let's say the switch is thrown and UTM is deployed throughout, we're just talking about the United States. Who and how will they be paid? How do they make oodles of money?
So the visual line of sight sort of UTM companies are paid based on an operator model. The operator would hire them to use their UTM, and that could be on a subscription basis. Per month, we're going to manage your flights and we're going to make sure you're in the network. The FIMS is different. What we're doing is going into a country and providing an application under a multi-year contract. So it's a singular sort of win. You can't have multiple doing FIMS in a country. So we're going after that kind of model. And there's a few other companies that are doing that as well. Those seem different, right? When you're looking at FIMS, it's the appliance, it's the one-time sale, it's the long process of maintaining a contract for many years. And then there's the operator, which is on a per flight sort of model and more of a subscription-based model. And I think that one is probably more, you have to be tolerant to what somebody's willing to provide, because if you start charging too much for that service, then it might not be the best thing to do with a drone anymore. We want to make sure that drones are lower cost and efficient, in terms of operational cost.
10 years from now, UTM is deployed throughout the U.S. How many UTM companies are there?
Oh, boy. I think you'll see a lot of UTM service suppliers. Mm-hmm. You could see dozens in the U.S. I guess it depends on how profitable it is for those UTM service suppliers to provide operations. Larger companies, Wings, Walmarts, Amazons, may have their own UTM service supplier because they find it more efficient to operate. And so the other UTM service suppliers that are out there in the US are picking up the volume of everybody else that doesn't want to manage the development and maintenance of a UTM service supplier on their own. And so then we're fighting for that, the extra that's out there. So I think that there is a limit for that. Right now we're seeing probably on the order of 2 to 4 companies that have gone through all these testing events and really making sure that your UTM is operating the way that it should and impacting safety. So I don't know, maybe you'll see many more operators for larger companies, but you'll see a smaller number of companies providing UTM service supplier for the rest.
Tell us about OneSky. We've talked about your company a little bit throughout the podcast, but tell us about it and what makes it novel, and why do you think you'll be one of the many companies in the next 10 years that'll be making a lot of money doing this?
OneSky was born out of AGI, which is our parent company, and has been around for 34 years. And most of the people in OneSky come from that company with a great understanding of modeling and simulation of systems. So that means communication systems, radar systems, surveillance systems, and knowing how these things impact safety of flight. So we have this great understanding, and we have an aerospace heritage that's different from many UTM companies that are out there. And we try to put that into the software. So when we talk about a rule-based approach to flight authorization, we're thinking about, well, the systems that are supporting your flight, let's make sure that they work. And where they don't work, maybe we shouldn't approve that flight in those locations. So it's a much more analytical approach to UTM than you might see from other companies. And I think it supports that flight information management system approach. So we're heading down that path right now, but at the same time, we're building other product called Operations Center, which is how do we tie in all the other stakeholders into the UTM? And certainly USS and the flight operator is one of those, but there's other stakeholders too. There is public safety. So if you're a law enforcement official and you want to create an area where drones shouldn't fly, how do you do that in UTM? UTM is different than ATM in that it's an ecosystem that has more stakeholders than just aircraft and air traffic controller. It impacts people at low level, and so there's more people that need to have their hands in the system. So public safety is one. You might want to know where drones are flying from a remote ID perspective, so you can have an RID system that's impacting the UTM. There's registration systems that we have that we would be deploying and tying in. There's mobile devices that are tying in. So the Operations Center is the next focus that we have in terms of tying in the operator to that back-end network. And then a big focus of ours is to keep our eyes on what's going on in UAM, the urban air mobility, and what's going on with the eVTOL market. vertiports and how those aircraft will eventually fly in the airspace as well. They're challenged by different things. One of our focuses now is on corridor operations, how you can fly through corridors, how an UTM would manage a corridor that's used by many different air taxis, the rules for how they fly through the corridor, the traffic flow management in the corridor, and how that integrates with traffic flow management outside the corridor in air traffic controlled airspace. So there's a lot of research and development into the UAM area at this point. So that's our approach is FIMS now, let's get the infrastructure going, focus on the operator and integrating them in, and then looking forward to UAM and how those vehicles will be flying differently.
What do you think the drone industry and UTM look like in 5 years from now?
I just hope that we solve this conspicuity problem, that people have a way to share their track data, their flight plan data for the interest of safety. And if somebody wants to do it and there isn't a mechanism to do it, then I think that's wrong. And I think the government has failed them in some way. So another one of my roles is I serve on ACJA, which is it's a GSMA function. GSMA is an industry association for cellular. And I think that existing infrastructure like what's provided by the mobile network operators, this cellular networks, can really solve a lot of these problems. We all have a cell phone in our pocket. Why isn't that the number one way we share position information and then lean on other things if you don't have cell service? But I think that we need to look at things differently. We need to look at the idea that third-party systems aren't bad. If it's not aviation grade, it doesn't mean it's not beneficial. How do we balance safety as well? Drones can do a lot of good, even if there's some risk. And we just need a holistic approach to looking at that. So I hope we get to a more cooperative sense of sharing information for the purpose of safety as number one. And then we looked at a risk-based approach to allow for drones to do the good that we think that they can do. And I think if we focus on that, then you'll see UTM explode, because I think that that's the fundamental system you need to have to unlock the ecosystem.
Chris, you come from a fabulous company with AGI, with their foundation in space, and then you start OneSky, and you've got a lot of experience in advanced air mobility here. What piece of advice would you give to somebody who wants to start a business in advanced air mobility, not just UTM?
Somebody told me once, keep showing up. That person will know who they are. But that's the thing. I mean, it's been 8 years now, I suppose, since we started OneSky, and we just keep showing up and keep making sure we understand what the new technology is, and we have a long approach to it. I mean, you can't solve this problem in one day. I think many people thought they could, are now not in business anymore. And you have to have a desire to do this. Aerospace is challenging. It's not something that we're going to solve in a day or two. It requires a regulatory approach and dealing with policymakers. And I think that's the most important thing to understand. You can't just come in here and have a great idea. You have to come in here and have a great idea that also fits with policy and regulations.
How do you want to wrap up the podcast, Chris? What do you want to leave with the audience?
I think OneSky has this strong desire to change the way that this industry is working, and we don't want to do it alone. And I would encourage anybody that's in the industry to think about the ways that partnership can help solve these challenges. If we try to do everything on our own, and if we're not communicating and being transparent with even our competitors to share, to standardize, then it's never going to be finished. So it's an ecosystem, and so not one company can solve it. Figure out where you fit in the ecosystem, what you want to do. And once you pick that swim lane, then I think we can all be more efficient working together. I think that's probably where I would leave it is I would encourage partnership in this industry, because we need to all work together to get it done.
Chris, thank you so much. This was a really interesting conversation. Thanks for your time, and thanks for being with us.
Thank you, Luca and Peter and Jim. I appreciate the time.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.